Welcome everyone to the session about Opni. We'll be introducing and discussing AIOps for Kubernetes using Opni. Now to introduce the team, my name is Sanjay Nadavajala. I'm joined by my teammates Amartya and Yingbe. We are under the E&I org and have been working closely with Craig Jellick and Will Chan on this project. Now for today's agenda, we'll start with a discussion about the current state of IT ops and monitoring. Then we'll introduce Opni and how it can help you leverage data from your clusters to prevent failures and downtime. We'll then give a high-level overview of our tech and finally conclude with the demo. At any point, if you have a question, I highly encourage to join the Opni Slack channel and start a discussion there. Put yourself in the shoes of an IT ops professional. You use a variety of different tools that each help you accomplish something, such as ServiceNow for ticketing or New Relic for application monitoring. IT is becoming more noisy and complex by the day. The pace and volume of infrastructure and code changes are making it worse. Generally, teams are growing in size and using more and more tools to aid with monitoring, automation, and collaboration. But as the number of tools grow, IT ops professionals are being flooded with too many incidents, tickets, and notifications. This is because more and more monitoring tools are being adopted and used, but more tools doesn't necessarily mean more efficiency. It does mean that there will be more false positive signals coming in about potential incidents and threats, but less clarity around where to look in the case of an outage. Timely outage detection, investigation, and resolution remain a major challenge. That's where we see potential for machine learning and artificial intelligence to disrupt the market. Now to introduce Opni, which is Rancher's interpretation of applying AI to IT operations. Currently, Opni features log anomaly detection for Kubernetes. Future releases will include more features such as metric anomaly detection, correlation between metrics and logs, as well as remediation suggestions. Opni is currently a real-time streaming solution built on novel AI algorithms. We use Elasticsearch and Kibana to visualize the Opni dashboard. How does it differentiate from existing AIOps tools? Well, for Opni, you as the operator do not need to have any knowledge of AI or machine learning. Unlike some of our competitors in which you need a data scientist or a machine learning engineer to come in and configure your AI models, Opni features a single command install and simple, which is very simple to use, and Amartya will actually go over that in a few moments. Opni does not require high volume of logs to get started. Its AI models automatically adapt and learn from changes within your system. It comes with specialized out-of-the-box models focused on Kubernetes control plane data. Lastly, Opni is open source like many of the other Rancher products.
When it comes to installing Opni, it is a very simple process using OpniCTL, which is a one-line command installer. All you need to do on your end is to run in the terminal OpniCTL install. However, if you would like any additional information for which parameters can be set during the installation, simply run OpniCTL install -- help. For shipping logs over to the Opni cluster, the easiest way is to use Rancher logging. However, you can use any tool, whether it be FluentD or FluentBit, to ship over the logs to Opni. So what do I have to do to set this up? I'll retrieve the endpoint of the Opni service and point Rancher logging, or whichever tool I've chosen to use, to that endpoint. Additionally, it is also worth mentioning that down the road, we plan to build connectors to large monitoring services such as Datadog and Splunk.
Opni's log anomaly detection model leverages multiple cutting-edge machine learning and deep learning algorithms. And here I'm going to highlight two of them. First is Drain. It's a machine learning method that learns log templates from incoming log messages. It's a super lightweight model with lightning fast speed, and it can learn in a real-time fashion. It detects the changes in environment and help retrain our deep learning model. Second, NewLog. It's a deep learning method that learns semantic contextual information from logs. Although it's a heavyweight model, it provides state-of-the-art accuracy and offers capability to handle large amounts of data and also provide robust predictions. By taking the advantages of these different methods, Opni is able to offer fast, accurate, and robust model for log anomaly detection task.
Now we will show how to install Opni using OpniCTL. After, we will show how an operator would use Opni by simulating two faults.
Now let's look at an actual example where I'll be using the terminal to install Opni using OpniCTL. So if you remember from the slide, first I'm just going to run OpniCTL install -- help. That simply just tells me all the possible parameters that can be set. In this case, I'm going to provide a kubeconfig file and a path. So let's do that right now. And there, I should be installing. It's started. And it is finished. Literally in a matter of seconds from when I ran this command, it has already installed Opni. So it is extremely easy to use OpniCTL to get started, and you have Opni set up already.
All right, this is the Opni dashboard, where an operator can consume insights on their log messages as if it were a metric. It is built on top of the Kibana that comes with OpenDistro Elasticsearch. The Opni dashboard comes preset with 4 panels. The operator can get a bird's eye view on what's going on with the logs of their clusters. We will export each of these panels in just a bit. Before then, I'd like to explain what has been set up for this demo. We have 3 nodes dedicated to the control plane and etcd, and 3 worker nodes for all workloads. For this demo, we have deployed a frequently referenced microservices application named SockShop. SockShop is an e-commerce application that sells socks. It is intended to aid the demonstration and testing of microservice and cloud-native technologies. We will use it to demo the abilities of Opni. This is the architecture of the SockShop application. For our purposes, we've deployed the application about an hour ago, and traffic is being sent to this application with a simulation engine that mimics real user interactions. This in turn generates a fair amount of log messages, as we can see more than 6,000 logs in the last 15 minutes. Let us now inject 2 separate failures. The first one will be that we take down etcd in one of the nodes. The second one will be that we overfill the orders DB. That will result in an out-of-memory DB crash and a subsequent restart. At this point, I'm going to inject both failures. Okay, I've injected both failures. Both of them are trivial, but these are the types of failures that typically appear before a major system outage. Being aware of these in real time gives operators the insight to prevent major outages. If you don't have Opni and your metrics dashboard did not catch the failures we injected, you'd have no idea something was brewing in your system. There's no reason for operators to visit their logs unless they really need to, which leaves a massive blind spot. This is where Opni steps in and provides insights to what subset of logs amongst thousands, if not millions, should the operator focus on. So if we did not have Opni and we only had this discovery dashboard that comes with most log management solutions, we'd have no idea what to investigate, what logs are anomalous, which ones are normal. We would have no idea. So if we go to the Opni dashboard, it's indicating that there was a huge spike in suspicious and anomalous logs. There are 3 tiers of logs: normal logs that represent the steady state, suspicious logs that can be helpful to look at during outages, and anomalous logs that should be taken a look at in abnormal conditions like the 2 that we've just injected. The top right panel tells us the distribution of control plane anomalies to workload anomalies. Given the 2 failures we just injected, there are more than 20 times the number of control plane anomalies as there are workload anomalies. So we can't really see the workload plot, but it is there. The bottom left panel focuses on etcd and control plane logs that the operator would be interested in. If we take a quick look, it is clear that this particular IP address can't be hit in the API server. And we can see that the etcd components are also complaining about the same IP address, which means the other etcd components cannot reach the third etcd component at this IP address. So if we copy paste this in our Rancher server, we see that this IP address belongs to etcd running on this node. If I were the operator, I would log into that node and further investigate what's going on. The other failure that we injected is the database failure. So if we look at this bottom right panel, which focuses on workload logs that the operator should investigate, we see that there's already a bunch of Mongo related issues. So we see that there's connections that are being opened, new inbound connections. And if we keep scrolling down, we see available memory is less than system memory. This tells us, hey, like something ran out of memory. If we further expand this, we can figure out which host this log message belongs to, and we see that it belongs to orders DB. We see more Mongo related issues. So if I were the operator, I would probably look into orders and orders DB, those two services, because that's what Opni is indicating to us. Opni is meant to leverage AI with all the data that your cluster produces. Why not take advantage? You can even hook up Opni to Slack and email so you can get alerted when to head over to the dashboard and investigate what Opni found to be anomalous. This is an example of an alert that came through Slack from Opni just a minute ago. Thank you for attending. Visit opni.io, start the repository, and follow as we build out our AIOps solution.